So I'm going to be talking to you today about flexible React components. I've already been introduced, but if you want to follow me on Twitter, my handle is girlcode, and that's also where I will post these slides after the talk. So as mentioned, I really do love React. I am a die-hard fan of it. It's really the first JavaScript framework that really aligned with how I want to build components. So when I thought of this talk and what I wanted to share about flexible React components, what I've learned over 4+ years of writing React, I knew the technical part of this talk really, really well. So that's the how. But what I was forced to articulate was the why, and that's why I made the choices that I did. I knew to a certain degree, but I hadn't sat down and actually written it out before. So to start, I want us to think about what flexible means in terms of UI. I find that often this gets compared to being reusable, so they're comparative. So let's go through a little exercise about this, where flexible means reusable. So let's pretend that we have a UI component, and it doesn't matter what it is at this point, so I'm just going to represent it with a block. So we have our block, 4 corners, 4 sides. We're doing really well here. So when we get a new design that uses that same UI element, we feel pretty good, because we've already built this component, and we can reuse it. So these all have different colors, but that's just a matter of passing in a different class name. That's fine. They all share the same structure and behavior, except they don't. You get handed a design with a little bit something different for that last one. Sometimes it's got a tooltip. OK, so what we'll do is we'll add a tooltip prop, and then that will take care of that. OK, we're still OK. Oh, no. So now we've got another mock with a different thing, and now the UI has changed a little bit, so it could have a dot in there. OK, that's fine. We'll just add another prop, and this is taken care of. Oh, no. Again, we get this element with a new behavior, so now it might have a modal. OK, we'll add a with modal prop. I mean, that's just 3, and we're still kind of OK here. But then, let's imagine that we stop working on this component, and our coworkers instead are working on this component. They see some other designs. They need to make some changes. I mean, this is already built, so why rebuild it again when we could just add a prop and maybe augment this a little bit? Oh, and don't forget, we want to do some A/B testing, so we're going to add some stuff in for there. It's all temporary. Don't worry, we think. It's the apropscalypse. So our simple block component is now completely overrun with props. So what now? Is this component flexible? I mean, nothing's changed about its reusability. It's still handling multiple UI states based on what props you provide. But I'd argue that this isn't a flexible component, and that our idea of reuse can sometimes blind us to better, more flexible patterns. So I've dealt with a component like this before. I would guess that actually most of us have. Blessings upon you if you have not. The example I use about the block component is identical to a component we already have at my work. So I work at a company called ClassPass, and when I joined, we already had this component. So if you don't know what ClassPass is, and I expect you not to because we're not in Europe yet, we are a flexible fitness membership. So we allow you to sign up with us, and then you go and reserve classes at gyms, yoga studios, Pilates, things like that nearby. So most of our UI is comprised of class schedules. So you would see a yoga class, and then you would see this element called the CTA, the schedule call to action. I'm just going to keep referring to it as the CTA from now on. And that's that little button to the side. And that lets you interact with the schedule. So maybe you want to reserve a class, or you need to cancel a class that you already reserved. That's when you're going to interact with the CTA. It's one of our key components. It's next to every single schedule on the site. But it's also a surprisingly complex component. So I'm only showing 3 states up here, but it actually has 5. So if you're viewing schedules as a logged out user, you're going to see a join message prompting you to sign up. If you're logged in, you're going to see one of 3 different messages: how many credits the class will cost to reserve, a cancel message if you've already reserved the class, or a grayed out disabled state if you're unable to reserve the class. So if you have a class at the same time, we won't allow you to do that. And then if you've previously had a ClassPass membership but you canceled it, you're going to see a prompt to reactivate your membership. It also has 3 different behaviors. So it might open a modal, it might link to another page, or it might show a tooltip. And then to correctly determine which CTA I need to show, this is all the information that I need to know. So is the user logged in? Yes or no? What's the state of the user's subscription? What's the state of the class? I need all of this information just to show you this one button. And as I mentioned, when I joined ClassPass, this already existed. Someone had already written it. I first encountered it when I needed to implement it on a new page. And you can see as I scroll down that this is really long for just a button. We have, a switch statement, if else is in there, functional components. It's pretty crazy. And the history of this component is actually identical to the block component that I showed before. It started off as a very simple component. It's a button that you clicked to reserve a class. And then from there, more intricacies were laid on top of it. So it needs to show a tooltip. It needs to open a modal. It needs to have different messaging depending on your state. And we did add in like a bunch of A/B testing too. Great. So by the time that I needed to implement this component, it required 14 props. 14 props. Like, no matter the use case, you need to pass in 14 props for this component to work. And like, God help you if you forgot one of them, or if you needed to change the component in any sort of way. I mean, I couldn't figure out what was going on with this thing. So is this component flexible? The thing is, you can write reusable components that are inflexible. Reusable doesn't equal flexible. Yes, the schedule CTA is reusable, but what happens when it needs to change? Which prop can you safely take away? Which prop is needed for what UI state? These questions are actually really difficult to answer because the component itself is really difficult to understand. And if you can't understand it and you can't modify it, is it flexible? I would argue that flexibility is about more than reusability. It's about the ability to understand and augment. To me, that's true flexibility. I don't care if your component is used in one place in the application. If I can understand it and change it with ease, that's a flexible component. The opposite, unable to be understood, unable to be modified, those qualities make a component inherently inflexible. But now I need to stop talking about what I mean, and I need to show you what I mean. So we're going to refactor the schedule CTA. And we're going to start with, hands down, the best starting point for either writing a new component or refactoring one. We're going to write down our ideal API. So React is declarative. And this is awesome because we can start from a point of not how we're going to create this component, but what we want it to look like. This is a really important part of building truly flexible components. Often, we focus on how we'll make a component reusable when we should be starting with what it should look like, and then let that inform how we implement it. For example, the schedule CTA. If we focus on how we're going to render different CTAs all in this one component, it can lead us down the path we've already been. If-else statements, a switch statement, and that's imperative, not declarative. So let's focus on what we want it to look like. Our ideal API is one prop, the type. That's the entire job of this component. I give it a type, and it gives me back the appropriate CTA. And this is a significant change for this component. And I don't mean in terms of how many props are being passed in. We've made a fundamental change in the structure of this component because we pulled the logic out of it. So previously, the schedule CTA needed those 14 props to run some internal logic and then tell you what the CTA should be. But now, we've taken that render logic out. Putting business logic in your components is a very bad idea for some very good reasons. If you add business logic to a component, you've locked that component. It can't be reused with a different set of rules, which means you need to understand the logic to use the component or to change the component. And if you want to change the component, the logic in it, you'll probably need to add more props. So, by removing the business logic from our components, we're going to gain flexibility. We can understand and we can augment with much more ease. We can also reuse the component with different logic. So, since our ideal API removes the need for the embedded logic, we can pull it out into a separate function. And we no longer need the 14 props. A props glyphs avoided. Plus, we benefit from centralizing our logic, which is easier to reason about. And we can test our component separately from our logic. Now, I know sometimes it's really nice to have a drop-in component that just does something. You know, a little bit of magic is really great. But, you know, I want you to think about the level of magic that you're aiming for. We all know how certain card tricks work or how the rabbit in the hat works. It's in the hat. But like, other tricks are much harder to figure out. And so when you're thinking about your components and how you want to write them, please think about the level of magic, because it makes it harder for the engineer to augment the component later. So for the schedule CTA, since it's very vital to the site, it's everywhere on our site, it's the way our users actually interact with all of our schedules, I want this to have very low magic. And that's part of why I chose this API. I want to give the engineer who uses this some clarity about what's going on. Give it a type, get back a CTA. But I also wanted a simpler API. I'm aiming for engineers to use this component. I want them to be able to safely navigate it. And I want to not be kicking myself for code that I won't be able to understand after a few months of not looking at it. So now we have to decide what to do with the actual individual CTAs themselves. We built the schedule CTA API. Now let's decide how we are going to structure our CTAs themselves. And we've got a couple of options here. So option one, we're going to use a base CTA to change out the messaging and props based on the type of CTA. And then option two, we're going to write each CTA type as a separate component. So we would have a reserve CTA or a cancel CTA. If you're leaning towards option one, you might be thinking that since all the CTAs look similar, you could get some reuse out of a base component. Less duplication of code, one place to edit things, and this all sounds good. But each of these CTAs needs to be modified depending on the type. So for example, the join CTA is a link, but the reserve CTA is actually a button element. So are we heading down the same path of another props glyphs, trying to reuse one component for all of these? If you're leaning towards option two, you might be thinking that since the CTAs don't all share the same UI or same behavior, it makes sense to break them into separate components. You'll know where to make changes, and you can isolate behavior to a particular CTA. But you'll see some duplication of code, so you might need to update each component at some point, and that is a pain. I don't think there's actually a right answer or a wrong answer here. I just think there's options with upsides and downsides. So ultimately, what I chose to do was to combine them into an option three. I want a base component that handles some of the common UI behavior, but I want to break the CTAs out into their own components where I could specify some behavior. So this is the base CTA component. I want it to be really lightweight because its main job is to encapsulate the parts that might change more frequently, so something like the class name. And I also need it to not interfere between the differences between components. So, like the fact that some of the CTAs are buttons, but others are links via React Router, and others are actually A tags. So I'm going to take advantage of defaults in ES6 here, and I'm going to assign the button as the tag. But any specific CTAs that need a link or an A tag can override that. And I like this because we get to encapsulate the most commonly used tag type, and then we can override it. And it's going to be very clear in the CTAs that override it because we have to pass along a very specific prop for this. I'm also going to rely on the children prop to render the different CTA messages. So children is super useful for when you need a generic container to take in more specific child elements. So a very quick example of this is the bread component. So this is our generic container. And you're seeing I'm passing in this.props children. So whatever you put inside the bread can be different. So that's just a nice way of thinking about children. So as an alternative to the children prop, we could have just passed in a message prop. So the message prop would be like join, reserve, disable. But I find that less useful in this type of component. One thing is that we use React International. So for these various messages, I'd be passing in a component and not a string. And when you're doing something like that, passing in a component via a prop, I'd urge you to consider using children instead. It's a more flexible declarative option. You can change the children components, the internals of the container, without needing to change the container itself. For our uses in the schedule CTA, we only need to know that whatever we wrap the base CTA around will be available as the children prop. So here I'm wrapping a formatted message component from React International to show the credits it costs to reserve the class. So we're taking a generic component, the base CTA, and giving it very specific children, as well as specific props, like the button primary class name. And I can also make sure I have specific behavior. So the disable CTA doesn't do anything when a user clicks on it. So I can ensure that an on-click handler, even if accidentally passed into this component, never gets called. As an engineer, this is great because I can specify behavior per component. So when the join CTA needs special analytics tracking, I can do that without touching any of the other CTAs. And since the reserve CTA needs to open a modal, I can do that. And I don't need to worry about accidentally introducing a change to another CTA. And I can test each of these individual CTAs for specific behavior to them. And changes to a CTA component are isolated to that component. And we've also added some flexibility that wasn't there before. So we can use the CTAs alone now. So this is our upcoming classes page. And since a user has already reserved these classes, all we want to show is the cancel CTA. We don't want to use the schedule CTA component here and pass in different things. It's only ever going to be the cancel CTA. And previously, with the old schedule CTA, we couldn't actually do this. In fact, someone wrote a completely new cancel CTA just for this page. But now, because we have these lovely separate CTAs, I can just put the cancel CTA on this page. OK, so now we have our base CTA, which is used to create individual CTA components. But we also have to go back to the schedule CTA, because it's not complete yet. We're giving it a type, and we have individual CTAs, but we need to figure out how the schedule CTA knows which CTA to return. Now, we could use a switch statement inside the schedule CTA. I mean, that's valid. But looking at our ideal API, I think I see a better option. So we give the schedule CTA a type, and it gives us back a CTA. And this reminds me a lot of requesting a key from an object. So let's use that pattern. We'll create an object with keys and values that correspond to the type and its component. Now we'll use the type prop to grab the correct component to render. If you're wondering why I'm assigning this component, this to a component with a capital C, React allows you to dynamically render components, but the component needs to be capitalized. And that allows React to tell the difference between something like a div or a span tag and a user-defined component like our CTAs. And dynamic component names are a really nice method for cutting down on switch and if-else statements in your component. So here I'm deciding between a left and right sidebar using an ES6 string template. And then here I'm deciding if I need to wrap the content in a card or not. These are just nice little examples. And then this is actually our schedule CTA after our refactor. So it's much smaller. There's no scrolling, as you can see. So it expects a type prop. If that isn't provided, we're going to return null. And then we're going to grab the correct component and assign it to a dynamic component name. And then we're going to pass our remaining props to that component. Now, we only had one prop on the schedule CTA, the type. So what are these other props that we might pass in? Well, I kept calling it the ideal API because at some point it's going to change. We're going to need to provide some more props to it at some point. Like, for example, we want to add in a class name so engineers can customize the styling. So you always start with the ideal API, and then as you build it out, you're going to find what's the more realistic API, like the things you actually do need to pass in besides that. So this is the realistic one. This was after I was done. So we've gone from 14 props to 4. Most of the schedule CTA, all the CTAs, they need the schedule information. Pretty much all of them do. And then I chose to pull like the tooltip out of the component, so it doesn't handle the logic for the tooltip either. So then after this refactor, we can use whatever logic we want. We can use individual CTAs alone. And we can add and remove the CTAs with much more ease, because it's just that object now, so you literally will just take it away from the object, and it won't be on the site anymore. So, was all of this work worth it? This is everything that happened since I rebuilt this CTA. So we added and removed A/B tests. We decided not to show the disable CTA on some pages, so it needed a little bit of different logic. The class names actually changed. We went through a rebranding. The messaging changed for the reserve CTA, and there was like a very specific ask for the join CTA on a specific page. And I couldn't do really any of this before very easily. All of this became so much simpler after this refactor. So it was absolutely worth the time. So we've finished the schedule CTA now, but I want to keep going. I want to work on a nicer option for all of this business logic that we pulled out in the first part of our refactor. Like right now, it's all in a function. So if I want to use this with the schedule CTA component, I need to import it separately. And that's low magic, but high annoyance. And I want the right level of magic. So to do this, I'm going to show you one of my favorite React patterns, the render props pattern. It's also known as children as a function. So I spoke about the children prop earlier, and while that can be child components, it can also be, honestly, anything, an object, an array, a string, a number. So what if it was a function? We could do something like this. And don't panic if this isn't immediately clear to you. I think the first time I saw this pattern, I really didn't know what was going on. And then once I figured it out, I fell in love. So what's happening here? This is a function that we pass as the children to get schedule CTA. It's going to expect a type, and it's going to pass that type to the schedule CTA. Inside of get schedule CTA, we're using that function to get the type. And then we're going to call the children function that was provided to us, passing in the type. And that's how the render props pattern works. You pass in a function as the children, and that prop is called with the information that it needs. This is a really powerful pattern. You can separate out the logic the component that handles the logic from the actual rendering of the UI. With render props, you delegate the rendering to the child function, it can return whatever UI it wants to based on the information it receives. So for the schedule CTA, this is a nice option to create declarative logic around the component. And I can export the schedule CTA wrapped in its logic, which avoids the need to import a separate function. Render props isn't a new pattern, but it's gained a lot of traction recently. In fact, even though it's been used in libraries like React Motion and React International for quite a while, it now has official docs at reactjs.org. So if you want to read those, please do. They're very informative. And then if you want to play around with the full potential of the render props pattern, I recommend the Downshift library. It's by Kent C. Dawes. It's an autocomplete component. Definitely check it out. But of course, I want to caution that render props is one tool in the toolbox. I'm often guilty of seeing a pattern like this and then wanting to apply it to everything. Which brings me to the part of the talk that I really hadn't expected to write. I thought this talk would be mostly technical, but in some cases, the why of building flexible UI isn't tied to the technical. It's about how you approach code as an engineer and how that impacts what you write. So I have this ongoing joke with a friend of mine. He loves lifting things. And I know that sounds very weird, but he lifts weights as a hobby, like very heavy weights. And he loves lifting anything heavy. Like he'll just go up to something heavy and pick it up for fun. It's very weird. So one day I joked that it would be really easy to trap him somewhere. Like if I just put like a heavy dumbbell somewhere, like he's gonna instinctively go for it and I could just throw a net on him. Like I could catch him so easily, like amazingly easily. It's really important to know your traps. I told him this, I was like, you have to know your traps. Like if you see a dumbbell on the sidewalk, like that's a trap for you. Like it's not just there, like someone's trying to trap you. So like what if placed on the sidewalk in front of you, would you like instinctively go for and someone could just throw a net on you? And the more like I did this joke with him, the more I realized it was part of also becoming a really flexible engineer. You need to know your traps as an engineer. Do you, like me, want to use new patterns right away instead of waiting for the better use case? Do you love one particular pattern and keep reusing it? Or do you have a tendency to stay stagnant and not learn new patterns? All of these are traps, and all of these will keep you from writing better components. And once you've written those components, are you willing to kill them? So I come from actually a background of creative writing. I taught myself engineering like 8 or 9 years ago. And kill your darlings is a very popular saying in the creative writing community. What it means is if you've written a story and there's a character that you really liked, or a line in your poem that you really liked, or just even a word that you really wanted in your story, but overall it's not working for the entire piece of work, you need to kill it. You may be very attached to it, and I feel like a lot of the time that I write code, I am very attached to what I build. But I also need to be careful that I can kill it when I need to. So the schedule CTA, even though I've refactored it, at some point it may not work for this anymore, and I have to be willing to kill it or let someone else kill it. So to summarize everything in this talk, start with your ideal API and let that API inform the component design. Decide what level of magic you want and keep business logic out of your components. Render props is an awesome pattern, definitely use it. But remember that being flexible as an engineer is really important as well. Know your traps, kill your darlings. Thank you.